In a problem like this, it is helpful to first be able to picture the sample space for the particular experiment. So you'll notice in this particular problem, they tell you that 2 dice are rolled. Now, you can draw a tree diagram if you want, and so basically the tree diagram would look like this. So if I rolled the first die, it is going to either show a 1, a 2, a 3, a 4, a 5, or a 6. And then if I rolled the second die, even though they can be rolled at the same time, you're still thinking of it as rolling one die and then rolling the second. The second die can also be a 1, a 2, a 3, a 4, a 5, or a 6. So you could draw the tree diagram like this and then list all the outcomes. Or I just find it easier to list all my outcomes in a table. And so I know that if the first die is a 1, the second die could be either a 1, a 2, a 3, a 4, a 5, or a 6. And if the second die is the first die is a 2, my second die could be a 1, a 2, a 3, 4, 5, or 6. If the first die is a 3, the second die could be a 1, 2, 3, 4, 5, or 6. If the first die is a 4, the second die could be a 1, 2, 3, 4, 5, or 6. If the first die is a 5, the second die could be a 1, 2, 3, 4, 5, 6. And I know it seems time consuming to write all of these out, but it just makes it so much easier to then answer the questions. So that would be my sample space. Now, I am looking for the odds in favor of rolling a certain sum. So the first particular question, they want to know the odds in favor of rolling a 5. So as I look at my sample space, I want to look at all the outcomes that have a sum of 5. And so we would say there are 5 outcomes. And normally, with probability, we would say 5 out of 36 total. But when you're talking about odds in favor, you look at the number of ways you can do it, and you compare it to the number of ways you can't. And so if I wrote it as a fraction, if there are 5 ways to get a sum that equals 5, that means there are 31 ways to not. And so a lot of times I like to write it with the colon as opposed to the fraction, so I'm not thinking that somebody's not assuming that it is like the probability. But that would be the odds in favor of rolling a 5. So the second question, they want to know the odds in favor of a sum greater than 4. So when I look at my sums that are greater than 4, that would be everything below this green line. So that would be my sums of 5, 6, 7, 8, 9, 10, 11, and 12. Now, it's easier to first think about the sums that are not greater than 4. So notice if I count those, there's 1, 2, 3, 4, 5, 6. So if 6 sums are not greater than 4, that must mean that 30 of the sums are. And so if 30 sums are greater than 4, you compare that to the 6 sums that are not. And we can talk about reducing. So those numbers are both divisible by 6. And so that would be the same as saying your odds are 5 to 1 in that particular case. All right, the third question wants to know the odds in favor of rolling a sum that is less than or equal to 7. So my sums of 7 are going to be here along this main diagonal, and then of course everything below it. So that would be my sums that are less than or equal to 7. So I could just straight out count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So there are 21 sums that are less than or equal to 7. And since I know there's 36 total, then that must mean there are 15 sums that are not. And so again, both of those numbers are divisible by 3. So if I divide both by 3, I get odds of 7 to 5. And then finally, the last question asks about the odds in favor of rolling a sum that is an odd number. So my odd number sums would include sums of 3, which are these, sums of 5, which would be these, sums of 7, sums of 9, and sums of 11. So if I count those, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 sums are an odd number, which also means 18 sums are not, and those are both divisible by 18, so my odds in that case would be 1 to 1.